Center of mass. The center of mass, or gravity, of a body is defined as the point where all the weight or mass of the object may be considered to act. In other words, a body behaves as if its whole mass were concentrated at that point. Center of mass of a body depends on its geometrical shape. For a simple rigid object with uniform density, the center of mass is located at its geometrical center. For example, center of mass of a square is at the point of intersection of its diagonals. Center of mass of a sphere is at its center. Center of mass of a rigid bar is at the middle point. The position of the center of mass of a body affects whether or not it topples over easily. This is important in the design of such things as tall vehicles, which tend to overturn when rounding a corner, racing cars, reading lamps, and even drinking glasses. A body topples when the vertical line through its center of mass falls outside its base. Otherwise, it remains stable. Pay attention. The man pulls the body, but the vertical line through its center of mass falls within its base. So no moment is produced. The body does not topple. The man pulls the body, but the vertical line through its center of mass falls within its base. So no moment is produced. The body does not topple. The vertical line through its center of mass falls within its base. The body is about to fall, but not yet. Now, the vertical line through its center of mass falls outside its base, and the body topples. Example. The diagram shows a 3-meter uniform beam AB, pivoted 1 meter from the end A. The weight of the beam is 300 newtons. A. Add arrows to show the following forces: the weight of the beam, the contact force on the beam at the pivot, center of mass of a rigid bar is at the middle point. The weight of the beam. This is the contact force on the beam at the pivot. B. A third force F presses down on the beam at the point A. What value of F is needed to balance the beam? See the diagram. Let's draw the distances. Let's apply the law of moments. Solve this equation. Remember, the weight of the beam is 300 newtons. Another example. The diagram shows a man standing in an airport with his wheeled bag. The man applies an upward force to the handle of his bag to stop the bag from falling. The moment of this force about the pivot is 30 newtons meter. Calculate the upward force the man applies to the handle of his bag. Moment is force times distance. D is perpendicular distance of the force from the pivot. 30 is F times 0.6. The distance in meters. F is 50 newtons. B. When the man lets go of the bag handle, the bag falls and hits the floor. Explain why. Look at the diagram. The line of action of the weight lies outside the base.